So continuing on, next, let's talk about program editing and commissioning. So editing is the ability to make changes to an existing program through a variety of editing functions. Using the editing functions, instructions and rungs can be added or deleted, addresses, data, and bits can be changed. Commissioning a PLC system involves a series of tests to ensure that the PLC, the ladder logic program, the I/O devices, and all associated wiring operations are operating according to specification. Before applying power, disconnect or otherwise isolate any output device that could potentially cause damage or injury. Apply power to the PLC and input devices, measure the voltage to verify that the rating voltage is being applied, examine the PLC status indicators lights, the power is properly applied, and the power indicator should be on and there should be no fault indication. Verify that you have communications with the PLC via the programming device. Make the PLC, place the PLC in a mode that prevents it from energizing its output circuits. This mode will allow you to monitor input devices, execute the program, and update the output image file while keeping the output circuits de-energized. Manually activating each input device to verify that the PLC's input status lights turn on and off as expected. Monitor the associated conditions instructions to verify that the input device corresponds to the correct program address and that the instruction turns true or false as expected. For testing, manually test each output. One way you can do this is by applying power to the terminal where the output device is wired. This test will check the output field device and its associated wiring. After verifying all inputs and outputs and program address, verify all present values for counter timers and so on. Reconnect any output device that may have been disconnected and place the PLC in the run mode. Test the operation of an emergency stop buttons and the total system operations. So there's a lot of things you want to be doing before you actually are ready and safely to go into operation. Next, for programming and monitoring, offline programming involved writing and storing the program in a personal computer and then later downloading it to a PLC. This is what we're trying to illustrate here in the image. And then you want to be uploading a program to so you can have a connectivity going from the PC to the PLC, and then you can have things from the PLC back to the computer to see how things are working. With online programming, the program can be modified while the PLC is working. Can be a useful feature. Offline programming is the safest manner in which to edit a program because changes do not affect the operation of the system until the downloaded to the PLC. The PLC continuous test mode lets the processor operate from the user program without energizing any outputs. This feature allows the control program to be executed and debugged while the inputs are disabled. PLC single scan test mode allows the processor to complete a single scan of the user program each time the single scan key is pressed with no outputs being energized. Data monitoring allows you to display the data from any place in the data table, so that can be a useful thing. For cross-reference, functions search all program files to locate each instance of a selected address. A user can then trace the operation by finding all the places where a particular output coil or contact with the same address is used in the program. You can also have a contact histogram, which is a function that allows you to view the transition history, the on and off status of the data table value, the status of the bits and the length of time the bits remain on or off are displayed. The delta time of the contact histogram indicates the elapsed time between the changes in states. Contact histograms are useful for detecting intermittent problems, either hardware or logic related. Then getting into preventative maintenance. Any filters that have been installed in enclosures should be cleaned and replaced to ensure the air circulation is present inside the enclosure. Dust or dirt accumulation on the PLC circuit board should be cleaned. Connections to the I/O module should be checked for tightness, and all field I/O devices should be inspected to ensure they are adjusted properly. Final check, care should be taken to ensure that heavy noise or heavy generator equipment is not moving too close to the PLC. Check the condition of the battery. That would be useful. That backs up the RAM in the CPU. Stock commonly used spare parts so that you can readily keep it operational and keep a master copy of the operating programs used. Use lockout and tagout procedures to make sure the equipment does not operate while the maintenance and repairs are conducted. In addition to disconnecting electrical power, all other sources of power, pneumatic and hydraulic, should be de-energized before someone works on a machine or process controlled by a PLC. And then looking at troubleshooting, the processor performs error checking and sends status information to indicators that are normally located on the front of the processor module. So you're going to have on steady, off, and on steady. So for things like run or battery and filter, all those are things that could be useful. Watchdog timer can be a benefit. Most PLCs incorporate a watchdog timer to monitor the scan process of the system. The watchdog timer is usually a separate timing circuit that must be set and reset by the processor within a predetermined period. The watchdog timer circuit monitors how long it takes the CPU to complete a scan. If the CPU scan takes too long, the watchdog major error will be declared. Here would be an example of input malfunctions. Narrowing down the problem source can usually be accomplished by comparing the actual status of the suspect I/O with the controller status indicators. I'm not going to go through this, but here are some troubleshooting guides that would be handy to help you to trace down where an error is occurring. In addition to the logic indicators, some output modules incorporate either a blown fuse indicator or a power indicator or both. Electronic protection is also used to provide protection for the modules from short circuit and overload current conditions. Here, again, I'm not going to go through this chart, but this is another area of output troubleshooting that can be helpful. Here is a typical output malfunction. Once again, I'm not going to go through this. This is in a textbook where you can pause and work your way through this. Many PLC software programs offer various software checks used to verify program logic. So you can selecting edit and then verify projects will check the program for errors. Good thing to do before you upload it and try and see if it's operational. Ladder logic program itself is not likely to fail, assuming that the program was at one time working correctly. You can have a hardware failure, and the memory could alter the program, but would be a PLC hardware failure. If all other possible sources of trouble have been eliminated, the ladder logic program should be reloaded into the PLC from the up-to-date master copy. Although the ladder logic program is likely not to fail, the process may be in a state that was unaccounted for in the original program and thus is not controlled properly. In this case, the program needs to be modified to include this new state. You start program troubleshooting. You can trace back from the output of the non-functioning run. Common logic errors include programming and examine if closed instructions instead of an examine if open or vice versa, and using an incorrect address in the program. Force on and force off allow you to turn specific bits on or off for testing purposes, so that can be something that can be useful. You can have a temporary end instruction to use, so you can pause and get into a single step type of mode. That can be a benefit. And the instruction operates only when its run conditions are true and stops the processor from scanning any logic beyond that point. So this is how you can start to put temporary ends as you're starting to go one part at a time. The suspend instruction is used to trap and identify specific conditions. So this would be useful for troubleshooting. So the rung is true, the instruction places the controller in suspend or idle mode. So this is something that you can be leveraging. Most PLC systems fault occurs in the field wiring and device. And so that would be something that you definitely wanted to be mindful of. The wire between the field devices and the terminal of the I/O modules is a likely place for problems to occur. You can have situations where you're using the same address, and so that's something you want to be double checking to make sure that that doesn't happen, or fix it if it has happened. And there are various methods of troubleshooting. Since we're getting an introduction to how to program, I'm not gonna focus too much on troubleshooting methods, but trying to be systematic in a logical fashion, one step at a time, is really what you want to be doing. And here is a troubleshooting tree. That's a nice kind of algorithm for you to be thinking about how to follow. And then we have a troubleshooting guide here over a couple of slides. The input troubleshooting, output troubleshooting, take a look at those. And for programming software, you must establish a way for your personal computer software to communicate with a PLC, some kind of connection. Making this connection is known as configuring the communications. And some of these gets into the device specific things. And so the RS logic or RS links, those are stuff that you want to be considering. So the RS links program is used as the driver between your PC and PLC programmer. That is something that you can be using. And so as a conduit for making sure that you're having connectivity to do those, using an RS-32 standard cable is something that is an example of how you can be doing that programming. Maybe it's USB, but that would be something that is not shown here as a possibility. So then this is just getting into a few last details about putting things together with an RS-232 standard and how to verify that your communication is working properly. And so I'm just going to skip over these. This is an RS-WHO is RS Links Network Browser Interface. And so that might be something that you might explore if you actually have a device that you can play with. And this is just some more continuation on that. All right, thank you very much.